In this video, we're going to look at the definition of a linear inequality. We're also going to explore how it's both different than a linear equation and similar to a linear equation. To start, a linear inequality is a statement about the relationship between two linear expressions using one of the following symbols: the less than symbol, the greater than symbol, the less than or equal to symbol, and finally, the greater than or equal to symbol. As a quick reminder of how each of these are used, I'll show a couple numerical examples. So we could state something like 3 is less than 5. We could state something like 6 is greater than -2. We could state something like -4 is less than or equal to -4. And we could state something like 5 is greater than or equal to 5. These are all statements using the inequality symbol that just involve numbers. A linear inequality is going to have a linear expression on each side. So just to recap a linear equation, let's look at an example of a linear equation. And then we'll write a similar one that's an inequality. So something like, here's a simple one, 2x plus 1 equals 7. Now, intuitively, we're taking 2 times some number, adding 1, and then that expression is equal to 7. So if we think quickly what possible number x could be, we can see that the solution to that equation would be 3. So I'm just going to add this over here. The solution is 3. Now, something similar that would be a linear inequality, we could write something like 2x plus 1, and then now I'm going to include the symbol greater than or equal to 7. Any statement that had 2x plus 1, greater than or equal to, less than or equal to, greater than, less than, would be an example of a linear inequality. Now, as a key distinction here, we have the statement 2x plus 1 greater than or equal to 7. So that or statement is pretty critical, because when it's equal to 7, we know that the solution is 3. But because this says or equal, greater than or equal to, that greater than part tells us that all numbers 3 or greater are going to be solutions to this inequality. So the solutions here, there are many of them, in fact an infinite number of them. So the solutions are all numbers 3 or greater. And we will discuss how we solve that algebraically, how we represent that solution set, but for now we're just going to focus on conceptually. The solutions to that inequality are all numbers 3 or greater. Okay, as a final part, we're going to look at a couple expressions in context. So as we can see, the key difference here is both the symbol used and the solution set. So, key difference, I'll write that out. That's the symbol used and the solution set. If we want to capture how linear equations and linear equalities are similar, the key similarity there is that we have a linear expression on each side. So how they're the same, how they're similar, is that each side has a linear expression. Okay, and finally, we're going to look in context where we could see linear inequalities used. So if we had a statement like children 12 or younger, and I'll write that down, children aged 12 or younger, we would want all ages 12 or smaller. And so I'll use a variable capital A for age, and I would be writing that then A less than or equal to 12. And again, that 12 or younger is telling me that A is less than or equal to 12. Another example would be, let's take this. So say there's free shipping on online orders that exceed $100. So online orders over $100. So I'll use B for bill, and I'll say that B is greater than 100 there. So those are just a couple examples of where we would see a variable in relation to the less than or equal to symbol, the greater than symbol, and then of course we could also use the less than symbol or the greater than or equal to symbol.